Welcome back to the Runtime Error once again. I hope you are really enjoying the linked list series. So far, we have come across the introduction to the linked list. Then we saw the implementation part along with the traversal technique as well. In this video, we will be discussing the deletion part of my singly linked list. There are two types of deletion we will be performing. That is, first we will be deleting the first node, and in the second we will be deleting our last node. So to know more about this, how the deletion of the linked list works, let's get started. Now this is the example which I have to say. For example, I have a linked list of length 4. I have the values as 6, 7, 3 and 4, and these are the addresses, and the linked lists are pointing to its next as well, and this is my last node. Now what I need to do is I want to delete this first node. Now the question is, how can I delete? So it's really simple. Deleting the first node is really simple. So as I told you earlier that this is my data part and this is my next part which is holding the address of my next node. Am I right? This is the data part and this is the next part which is holding the address of my next node. And here it is a head which is pointing to my first node. So I need to delete this node. So what can I say? I need to simply break this bond and take this head to this position, so that this will get simply deleted, because head is my pointing to this second node. And whenever I say head, what does head indicates? The head simply indicates my starting point of my linked list, right? So my head is pointing to this location, which means can I say my starting point of my linked list is from my second node. So this will be my final linked list, which means this node is been deleted. So can I simply write head equals to head of next? Can I write this? What does it mean is, head basically contains 100. So head of next, so this is the node. So head of next will be 10. So where I need to put this 10? I need to simply put it inside the head. Am I right? So what it will happen? So this 100 will get deleted and it will contain as a 10. Now what will happen? So this link will get deleted and this will be pointing to this node. So whenever I call head, my linked list will start from this position. Have we deleted the first node? Yes. We can't say that we have deleted, but we can simply say that we have separated. So what to do in order to delete it? Because we know that we have allocated this node dynamically, right? But we need to delete it. So as a programmer in C++, it's a programmer job to delete dynamic memory. If you go in languages like Java, it has a garbage collection, so we don't need to delete in that language. But when it's come to C++, we need to delete it. So what we will do is I will simply keep one extra pointer to this location. Say for example, as called as temp. Now the question is, hey, why am I pointing this pointer to this node? Because this is the node which I want to delete. Now let's make it earlier as it is. So this was pointing to this and this contains 100. Now what will happen? I want to delete this node. So again I will perform the same thing, that is head equals to head of next. So this will get deleted, this will get erased and it will contain as a 10. So it will be pointing to this location. And now what I will do is, since I want to delete this node, I will simply use a keyword called as delete. Which pointer do I need to delete? Which node do I want to delete? That node is pointed by the pointer called as temp. So simply what I will do is I will simply put temp in this. So I hope so you understand how to delete the first node. Now we will check how to delete the node present at the last. Now let's take one more example. Say for example, we got 4 nodes once again, which contains a value as 7, 3, 1 and 6. This is pointing to null. This first node is pointing to head, which contains, here for example, address 10. So it will be 10. This contains 40. This contains 60 and this contains 100, so 100. So this is my linked list, and now what I want to do is I want to delete this node. I want to delete this node, this last node. How can we delete the last node? Since in the previous part we saw that we need to delete the first node, what we simply did is we simply moved this head to the next position. But the point is, how can we move this? And the second thing I told you about the linked list is one of the biggest drawback is we cannot traverse reverse in a single linked list, because the addresses are holding of a next address. There is no any point which is holding the address of its previous nodes. So we need to move to the front side only. And the point is we need to break this junction. I need to break this junction. How can I break this? Can I say in order to break this junction I need to move till my second last node? Can I say in order to break this node I need to come till my second last node? Yes. How can we come in a second last node? So we need to traverse the linked list as I told you, right? And at the same time what we need to do is we need to keep a pointer so that we can keep a track that we have arrived at my second last node. So if you don't know about how to traverse the linked list, I have already made the video of traversing the linked list. It would be much better if you observe that video if you don't know how to traverse the linked list. So here we will not be going in detailing to traverse, we will simply keep traversing. So what I will do is I will keep a pointer, say for example called as fast. Now why I am calling this pointer the fast, I will tell you afterwards. Now what I will do is I will keep going till my fast of next is not null. Now the question is, in the video of traversing the linked list I did the fast is not equal to null, but why we did here fast of next is not equal to null? The reason is because we need to stop over here so that my last pointer should come at this position. If I use here fast is equal to null, then what will happen? My fast will come at here and I wanted to come at this location, but unfortunately I will be present at the last node. But I want to delete this node. How can I delete this node being in this node? Because anyhow I need to make this as null, which will indicate my end of the list. So simply what I need to do is I need to make here null so that it shows my end of the list. And if it does not contain null, then what does it indicate? It is pointing to a location which is present. But the point is this is not a location which is present because we are going to delete it. So this is the reason why I am doing it. The fast of next is not equal to null, so that whenever my last pointer comes at here it should stop so that I can get the address of this node. So again what I am doing is again I will be keeping one more pointer called as say for example slow, which is pointing to again head as well. So what I will do is here is before taking my fast forward I will simply take slow to the position of the fast, For more simplicity let's make it as null. Say for example slow is initially null, right? I will write over here slow initially is null. Now what I will do is before taking my fast to the next position I will simply assign the value of fast to the slow. Now what will happen over here? My slow will point at this location and then I will take my fast equals to fast of next, right? Let's see what's happening over here. Now fast as assigned to null is assigned to fast, so it will come here. Now fast is equal to fast of next, so my fast will be moved to my next position, that is over here. Say for example I am naming it as F just for simplicity purpose. Now again it will come. Is fast of next is equal to null? No, this is not a null, so this condition gets true. Now slow equals to fast. Now slow will be pointing to this location and fast is equal to fast of next, so fast will be moved to the next location, that is over here. Now again we will come here. Is the fast of next is equal to null? No, fast of next is equal to 100, so this condition gets true. And now what will happen? Slow equals to fast, so my slow will be pointing to this location and fast is equal to fast of next, that is my fast will go over here. Now again we will come at here. Fast of next is equal to not of null, but the point is fast of next is equals to null, so this condition gets false and we come out of loop. Now can I say my slow is pointing at this location? Can I say my slow is pointing to at this location? Yes. Now what I need to do is I need to simply break this junction. So simply what I will do is, since I know that slow is pointing to this location, I need to make this null. So that this function junction get discarded. So what I will do is I will simply write it as slow of next equals to null. So what has happened over here? So this value get diminished, and over here the null has come, which means this has been removed. Now this single node is present over here. Now we need to delete it, and as I told you earlier, as a C++ programmer, it's our duty to delete this node. So simply I will use the delete keyword to delete the node. Which one is the node? Fast node. So simply what I will do is I will simply delete the fast. Now this will get missed. I hope so you understand the deletion of a last node as well. So that's it from this video. I hope you understand both the things, how to delete the first node as well as how to delete the last node. If you really love what I'm teaching, the way I'm teaching, I recommend you to subscribe this channel and follow this linked list playlist. Till then, have a happy coding.